The nonsensical and non-science philosophy in string theory and evolution theory. In the realms of theoretical physics and biology, string theory and evolution theory have both been subjects of extensive debate and controversy. While both fields have significantly advanced our understanding of the universe and life, critics argue that elements of these theories rest on philosophical grounds that stray from empirical science. This article explores the nonsensical and non-scientific philosophies underpinning aspects of string theory and evolution theory, using critiques and quotes to examine their foundational assumptions and scientific validity. String theory, a beautiful theory or a non-empirical philosophy. String theory emerged in the late 20th century as an ambitious attempt to unify the four fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, into a single theoretical framework. At its core, string theory posits that the fundamental particles we observe are not point-like dots, but rather tiny, vibrating strings, whose vibrations give rise to different particles. The critique of non-empiricism. Critics argue that string theory, while mathematically elegant, lacks empirical evidence. The theory is often criticized for its reliance on speculative mathematics rather than experimental verification. As physicist and author Lee Smolin pointed out in his book, The Trouble with Physics, string theory has produced no unambiguous experimental predictions. It has not been confirmed by experiment, and it appears unlikely to make predictions testable by current technology. This critique highlights a core issue. String theory has yet to provide testable predictions that would allow it to be falsified, a key criterion for any scientific theory. Without empirical evidence, string theory remains in the realm of philosophical speculation rather than concrete science. The problem of multiverses and dimensions. Another contentious aspect of string theory is the concept of multiple dimensions and multiverses. String theory suggests the existence of up to 11 dimensions and numerous parallel universes, but these remain unobservable with our current technological capabilities. The theory's reliance on such concepts, which are beyond empirical verification, has led some to question whether string theory is drifting into the domain of metaphysics rather than staying grounded in science. Philosopher of science Karl Popper famously stated, "A theory that is not refutable by any conceivable event is non-scientific. Irrefutability is not a virtue of a theory, as people often think, but a vice." In the context of string theory, this quote underlines the concern that its unfalsifiable nature places it outside the bounds of scientific inquiry. If a theory cannot be tested or potentially disproven, it risks becoming a speculative endeavor rather than a rigorous scientific framework. Evolution theory, science or scientism. Evolution theory, particularly the concept of natural selection as articulated by Charles Darwin, has been one of the most influential theories in the history of science. It explains the diversity of life through gradual changes over time, driven by genetic variation and environmental pressures. However, critics argue that certain aspects of evolutionary theory, especially the neo-Darwinian synthesis, are based more on philosophical naturalism than on solid empirical evidence. The limitations of natural selection. While natural selection is a powerful mechanism for explaining adaptation and small-scale evolutionary changes, some critics argue it falls short when accounting for the complexity and diversity of life. As biochemist Michael Behe, a proponent of intelligent design, argues in his book Darwin's Black Box, the result of these cumulative efforts to investigate the cell, to investigate life at the molecular level, is a loud, clear, piercing cry of design. The complexity of the simplest known type of cell is so great that it is impossible to accept that such an object was thrown together by some kind of freakish, vastly improbable event. Behe's critique highlights a fundamental issue. While natural selection can explain minor adaptations, it struggles to account for the origin of complex biological systems that appear to be irreducibly complex. Critics of Darwinian evolution argue that this gap in explanation leads to a reliance on philosophical naturalism, the belief that all phenomena can be explained by natural causes without invoking design or purpose. The philosophy of just-so stories. Another criticism of evolutionary theory is its tendency to rely on just-so stories to explain complex traits. These are speculative narratives that provide plausible, but not necessarily evidence-based, explanations for how a particular trait might have evolved. Evolutionary biologist Stephen Jay Gould criticized this aspect of evolutionary theory, stating, "Just-so stories are plausible tales, but they are stories rather than scientific theories. They cannot be tested or falsified, and therefore do not advance scientific knowledge." Gould's critique points to a significant philosophical issue: the use of imaginative storytelling to fill gaps in empirical evidence. When evolutionary biology resorts to constructing narratives without sufficient evidence, it risks moving away from the scientific method and towards speculative philosophy. A need for scientific rigor and evidence. Both string theory and evolutionary theory, in their attempts to provide comprehensive explanations for complex phenomena, have encountered philosophical and methodological challenges. The criticism that string theory lacks empirical evidence and relies on unfalsifiable concepts mirrors the critique that evolutionary theory sometimes depends on speculative narratives without rigorous testing. To maintain their standing as scientific theories, both fields must address these concerns. For string theory, this means finding ways to make testable predictions that can be confirmed or refuted by observation. For evolutionary theory, it requires a commitment to evidence-based explanations and a willingness to question narratives that lack empirical support. Conclusion. The debate over string theory and evolutionary theory illustrates a broader discussion about the nature of science and the importance of empirical evidence. While both theories have contributed significantly to our understanding of the universe and life, they must be continually scrutinized and refined to adhere to the principles of scientific inquiry. As science progresses, it is crucial to distinguish between what is empirically grounded and what remains speculative philosophy. Only through rigorous testing and evidence can we truly advance our understanding of the natural world.